Hello student, this is the second video of a series of chemistry O-level practicals. Let's look at how this student writes and some of the learning points. So this is a 2003 paper. What this student have done is highlighted or underlined what needs to be done, which is a good practice. As you can see over here, she highlighted important points, solutions to be added. Same thing over here. And look at what she has done on the table. Observation, add, no PPT, and observation again. These are some of the things that you should do when you receive a piece of practical. Let's go back to the question. First part of the question asks you to identify solid X. When you need to identify, it means that you have to tell the name of the cation and the anion of a solid X and give a proper name. Part A asks you to see which of the following statements are correct. 1, 2, 3. And she have written on how she should describe to see whether solid X is soluble in cold water, hot water, or not soluble in cold or hot, but soluble in dilute nitric acid. If you think carefully about this, if solid X is soluble in cold water, it should have no problem in dissolving in hot or nitric acid. So what she have described is simply this. Place a spectrum of solid X into a test tube. Add 10 cm³ of deionized cold water if you want it to be better. And then she described that solid X will dissolve to produce a colorless solution. I think this is a good enough answer. So she need not do 2 and 3 because it's already soluble in cold water. Dissolve half of the remaining solid to make about 10 cm³ of the solution X. I need to remind students that this statement is referring to the packet of solid X that were given to you. So when they say half the remaining solid, it means the solid given to you in the packet. So what you do is you take the solid and dissolve in water to make a stock solution of X. From this stock solution of X, you pour out 2 cm³ to do BI. Now what are you supposed to do this 2 cm³ of solution of X? You're supposed to add the sodium hydroxide and warm. Now if you notice carefully this action, add sodium hydroxide and warm, you are actually doing this action over here. Can you see? Add sodium hydroxide and warm. So you're actually testing whether the solution X contains any ammonium ions. If there is, you should see ammonia gas being produced. And so to see whether ammonia gas is being produced, you have to test with moist red litmus paper. And she found that the red litmus paper turned blue, meaning that ammonia gas is produced. Of course, ammonia gas does not support Lactose spin, so the Lactose spin goes off. From here, we can deduce that the presence of ammonium ions if they ask you to write some conclusion. Let's turn to the next page. To a second portion of the solution X, we're supposed to add barium chloride followed by nitric acid. If you notice this carefully, this action is referring to this action over here. Although it's written as barium nitrate, let me remind students that barium nitrate has the same function as barium chloride. And we should look at this column over here to see whether the solution contains sulfate. And so white PPT was formed, and we can conclude that there's presence of sulfate ions. Again, you need to take out another 2 cm³ of the solution X, and for the part 3, and you need to add silver nitrate and followed by nitric acid. Over here, if you refer to the table, we are talking about this. This section over here is supposed to look for any white PPT. Unfortunately, in this case, there's no white PPT, and we can conclude there's no chloride ions. So over here, we conclude that there's some sulfate, and over the first picture, the presence of ammonium ions, and therefore we can safely conclude that the solid X contains ammonium sulfate. Take note that identify and name means you have to write down in English, write out the English term for the compound or the substance. The last part needs some thinking. In this case, suppose to put solid X and calcium hydroxide into a test tube, heat strongly so that interact the gas to a solution of Y. Now Y has been given to you as copper sulfate. In other words, it contains copper 2 ions. Alright, what happens is this. When an ammonium salt, in this case is ammonium sulfate, react with a calcium hydroxide. In this case, you will heat strongly or either in solution form and warm. Ammonia gas is given out together with water and salt or calcium sulfate. So the reaction takes place inside here, but the water vapor or the ammonia gas produced over here get diffused over and transported by the delivery tube into the solution over here. So NH3 and water came out from here, dissolved in the aqueous solution of copper sulfate. Now, when NH3 dissolves in water, it looks something like that. It gives you aqueous ammonia. Now, if you think of it carefully, aqueous ammonia is being produced over here, and it's just like you add aqueous ammonia to a solution of copper sulfate. So what do you think will happen? You are correct. A light blue PPT will be formed, soluble in SS, giving a dark blue solution. And I think most of you got it correct. If you can't figure it out, let's look at the table. And there you have it again. Can you see? It's just like you produced aqueous ammonia, and when any aqueous ammonia is introduced into a solution of copper sulfate or copper ions, you get a light blue PPT soluble in SS, giving a dark blue solution. So there you have it. 203 is quite a simple paper, and the next paper that we'll discuss is 2005. Thank you.